All right, so I want to remind you of where we left off. We discussed the effective equivalent annual interest rate of an investment over T years, and we did an example where we verified the 3-year and 5-year average annual return, same thing as effective equivalent annual interest rate, for NB Global Equity in the table right here. So we verified that the 3-year average annual return for the beginning of 2012 to the end of 2014 was 20.19%, and for the full 5-year period was 11.08%. And again, I want to emphasize, despite the name average annual return, we're not literally averaging the interest rates. So, as I said in the previous video, please don't do that on quiz or exams, or I'll have to give you, have to mark it up, and I won't be too kind to it because it means you don't really understand this concept. But anyway, I trust that you won't do that. So, one comment about the effective equivalent annual interest rate is that equivalent, it's saying IT is the effective equivalent annual interest rate over T years. It's the same thing as saying, instead of the growth factor is given by 1 plus 1 IT to the T, it's the same thing as saying the accumulation function is A naught, your initial investment, 1 plus IT to the T. And the reason is very simple, because remember, the accumulation function is just A naught times A of T. In general, the amount of money you have in an investment after T years is your initial investment times how much $1 grew after T years. So you just take this and multiply by A naught, and saying this is equivalent to saying this right here. Okay, so saying the growth factor A sub T is 1 plus IT to the T is the same thing as saying the accumulation function is A naught 1 plus IT to the T. And it's just a little easier sometimes to work with the accumulation function, so you don't have to calculate the growth factor if you don't need to calculate it. Okay, so let's talk about different compounding periods. So there's obviously no reason why interest needs to be compounded yearly. You can compound it daily, weekly, monthly, bi-monthly, bi-yearly, etc., etc. So I'll try and stick to I for effective annual interest and use J for different compounding periods. Okay. So for example, let's say interest is compounded monthly at J equals 0.003 as a decimal, and that's for the first 6 months, and 0.004 for the next 6 months. How much will 2,000 grow in a year? And what is the equivalent effective annual interest rate for the year? Okay, so let's do the first one. So what this is saying is that every month this account grows by 0.3%, which is 0.003 times 100. Okay, so right, so we're letting this 2,000 sit in this account for 6 months. So we compound the interest 6 years. 6 months. Each month it grows 0.03%. So just by the logic that we employed in the first video, at the end of 6 months, it's 2,001 plus 0.003 to the 6th, which is $2,036 and roughly 27 cents. And after 6 more months, the same thing, except here, every month the account grows by 0.4%. So we compound this 6 times for 6 months. it's $2,036 and roughly 27 cents times 1 plus 0.004 to the 6, which gives you $2,085.63. So I'll round up everything to the nearest dollar when I don't have to do any more computations with it. Okay, and to find the equivalent effective annual interest rate, it's just the formula that I mentioned, so that we don't really need to calculate the growth factor again for 1 year. I mean, of course, you can just get the growth factor by really taking this number here and dividing by 2,000, your initial investment. But anyway, so we set it up as A sub 1, how much is in this account after 1 year, equals A naught, the initial investment, 1 plus I1 to the 1. And then we just solve for I1, the equivalent effective annual rate for this 1 year period. And we get 4.281%. And this example should really illustrate why it's useful to deal with an equivalent effective annual interest rate. When I see 4.281% effective annual interest rate, I think, okay, that's not too bad. That's something, it's a reasonable interest rate. Whereas when I see a 6-month interest rate of 0.3% or 0.4%, in my mind, I don't really know what that means or how to compare that to something else. It's just not something my brain registers as good or bad. So, right. So as you do finance and deal with investments in real life or in other courses, you'll get a perspective of what is a good annual rate and what is maybe kind of an anemic annual rate. And then you'll be able to put different rates in perspective. By different rates, I mean rates corresponding to different compounding periods other than a year. Okay, so anyway, when t is in years and you want to use your formula for compound interest, you can still plug in t if t is not an integer. You just have to make it as a fraction of a year. And the standard convention, the standard actuarial convention, and probably standard for other different fields, though accounting and different financial institutions might use something slightly different. But so for us, we're going to just keep things simple and assume there's 365 days to a year. That's true unless you have a leap year. 52 weeks to a year and 12 months to a year. Okay. So with this perspective, in the previous example, find the equivalent effective annual interest rate for the second 6 months. And before I say anything else, I should maybe make clear that in this formula, t has to be in years. Okay? It doesn't make sense for t to be in anything else other than years. Okay, so let's go back to this problem. Okay. So in this what we're going to do here is just get the growth factor for the last 6 months, for the last 6-month period. All right, and what does $1 grow to? Well, interest per month is 0.004. We're dealing with 6 months, so $1 grew to 1 times 1.004 to the 6th equals 1.02424, roughly $1.24. Now, alternatively, you could, if you wanted to, treat your A naught as $2,036.27 and just use this, but it might make more sense just to compute the growth factor for the last 6-month period and then just use that. Okay, so we go back to our definition of I 1/2. And here what we're going to do, of course, is I'm going to square both sides. Get my little pen here. So I want to get rid of the 1/2. So of course I'm going to square both sides. So for most of the course I'm not going to be so in detail with solving for things or put all that much math detail, but I guess for the first few lectures I will. All right, so we square both sides, subtract 1, and we get I 1/2 is 0.04907, just 4.907%. Okay. That's the equivalent effective annual interest rate for this 1/2 period, the second half of this year we're considering. All right. Okay, so another example. Let's say we have effective annual interest is at 3% and $6,000 is deposited. How much do you have after 5 days? Okay. And this is pretty straightforward. Well, we're going to treat 5 days as 5 over 365. That's fraction of a year. Okay, so when we have an annual interest rate, T is treated as if it's in years. So we plug this fraction in for years, and just plug and chug, and you get 6,000 times 1 plus 0.03 to this fraction here, which is $6,002.43. And also, how much do you have after 3 months? Do the same thing, plug in the fraction 3/2. Okay, so I plug in this fraction 3/2. 3 months is, sorry, not 3/2, 3/12. Because 3 months is 3/12 of a year. Again, interest is given as an annual interest rate, so T is implicitly in years. Just like in the previous example, we have a 1-month interest rate, so T is in months. Hence, 6 months means you plug in T equals 6. All right. So that was for this example here. Okay, anyway, so plug and chug, plug this into a calculator, we get $6,044.50. Okay, so that finishes up the first part of compound interest, and I'll put up another video soon, next few days, on the second part of compound interest. And then probably next week we'll dive into annuities. We'll kind of introduce annuities actually before we formally define them. But anyway, all right, so long, take care, stay safe, and expect a new video very soon.